Welcome you all. Today we are going to discuss about authentic requirement and authentication function from the unit 4. Myself Sherin Glory, Assistant Professor, Department of CSE from RMD Engineering College. So this unit 4 widely describes about message authentication and integrity. This is the first topic in the first unit, in the fourth unit given. So regarding this authentication requirement, first we are going to discuss about what are all the possible kinds of attacks in the communication network. It has been listed out over here. Number one is disclosure. What do you mean by disclosure? We have discussed about all these types of attacks in the first unit itself. Disclosure means it is release of message contents to any persons or a process without an appropriate cryptographic key is said to be an disclosure. Second thing is traffic analysis. So this traffic analysis, we are going to analyze the pattern of traffic between any two parties, and we are going to get some informations that is said to be an traffic analysis. And the third thing is masquerading. So insertion of some messages into some network fraudulent sources without an authorization is said to be an masquerading. And content modifications, changes to the original content. It can be a deletion or a insertion or transposition and modification, all comes under this content modification. And the fifth one is sequence modification. So here in sequence modification, we are going to alter the sequence of the messages by inserting some kinds of content over there is said to be, or reordering the contents, all comes under this sequence modification. And the sixth one is timing modification. Delay or replay of messages is said to be an timing modifications. If I send a message at one time, if it has been delivered to the person after some time, or delay because of some unauthorized event occurs, is said to be an timing modification. And the seventh one is source repudiation, and eighth one is destination repudiation. Repudiation means denial of some messages, or denial of services is said to be denial of some actions done by the user is said to be an repudiation. So here name depicts as source repudiation. So denial of transmission of messages by source. And destination, of course, the destination will be receiving the messages. So it means denial of transmission of messages by destination is said to be an destination repudiation. So these are all the possible types of attacks. So we have to take measures to deal with these kinds of attacks. The first two attacks are in or can be dealt with the message confidentiality, and the next third to sixth, that is from masquerading to timing modifications. If you are maintaining some message authentication mechanisms, then it will be easily be solved out. And the last two can be overcome by giving some digital signatures. These are all the possible attacks that can be possible because of some misleading, some fault in the authentication requirement. So now we have to know about what is message authentication, because this unit widely talks about the message authentication. So what do you mean by authorization or authentication? So it is a procedure to verify that received message come from the authorized person or not. And it also ensures that the meanwhile in the environment the messages has not been altered by any person. Okay, so that is said to be an message authentications. So so we ensure that authentication as well as data integrity. Data integrity means, as I said, it's not been altered anywhere by the third person. That is, insertion of messages has not been happened. Content modification, sequence modification has not been happened. That is what I am ensuring here. So message authentication, a digital signature is an authentication technique that includes some measures to counter the repudiations, because digital signature, as I said, a signature will be attached with the along with the messages. So the source or the destination cannot deny that they haven't raised such thing, or that they haven't sent or received such messages. So that's so by introducing this digital signature, we can overcome this kind of repudiation. And authentication functions. So what are all the authentication functions that are available to overcome these kinds of attacks? They can be grouped into three classes. Number one is hash functions. Number two is message encryption. And number 3 is message authentication code. So a hash function is nothing but a public function that maps a message of length into a fixed hash value. Whatever can be the length of the messages, it always maps to an fixed kind of length hash value, which can serve as the authenticator and which helps to know the person who has sent the messages is an authorized person. And then we have message encryption. So this message encryption, we have studied this about this encryption technique in the first and second unit. So a ciphertext will be sent to the entire message, which serves as the all the messages will be converted into some illegible form, so that no other third parties in the environment who are compromises the network cannot able to read the messages. And the last one is message authentication code. So this is a function, public key, public function of the messages and a secret key that produces fixed length value, which serves as an authenticator. So these are my three classes of authentication. Okay, so we all know that message encryption, we have symmetric key and public key encryption. Symmetric key means the same secret key will be used for both sender and the receiver. And public key encryption, here a private key will be used to encrypt the messages and the B's user key will be used to decrypt the messages. Two different keys will be used for encryption and decrypting of messages. So here we have given a diagram of what are the basic uses of message encryption. So message encryption, by symmetric key encryption, as I said, we have a single key which will be used for both encryption and decryption, that has been depicted over here in a diagram. So see here, it has been depicted over here in a diagram. Same key has been utilized over here. So whenever a message has been sent, it is encrypted with a key and it has been sent in the communication channel after the ciphertext has been sent, and at the destination process the same key will be used to decrypt the messages. So it is similar to like a lock of your house. A same key will be used for locking as well as unlocking. And next, here this diagram, second diagram tells about public key encryption. So when I am talking about public key, it is about going to use two keys. Okay, so here also it ensures confidentiality. The message has been encrypted using the public key of the user, that is user, and it has been encrypted, and then while the receiver receives, he always decrypt the message using the private key. And the third scheme, it ensures authentication and signature. So what do you mean by signature? Whenever a message has been encrypted using the private key of the user, then it is said to be an signature. That's why I have depicted as signature. Okay, so it is a private key which is known only to the concerned person. So whenever that key has been utilized for encryption, so it is a secret one. So using that key, I am doing something. I am converting into an illegible text. So it means it is it serves as the signature. And the final diagram, it tells about public key encryption again, and it ensures confidentiality, authentication, and signature. So the message is encrypted using the private key and it is sent in the communication channel. Again, it is again double encrypted using the public key of the receiver, and then it is sent, and the receiver and the remaining reverse process takes down. So all these diagrams depicts about what are all the basic uses, how this message encryption can be used to ensure the confidentiality and encryption. So we are talking about this message authentication code. This is the second category. As I said, it is used to used as a secret key to generate a small fixed size of block. It is always represented as MAC of C K, M, where M is input message and C is the MAC function and shared key. Okay, so it always, when A has want to send a message to B, it calculates MAC function for that message and it will be sent in the environment, and this serves as the authenticated purpose. Again, similar to your message encryption, here three diagrams has been depicted to show the how this MAC has been used. Okay, so when message has been sent, so it is sent to a MAC function and it uses a key and generates a MAC function for that message, and it is appended along with the original message and sent. and the receiver to ensure authentication. Authentication means to ensure that it is from the right person. So whenever the destination receives that particular messages, he is checking the appended information along with the message. So he is decrypting that, he is receiving that message, the appended information, and from the message he is calculating the MAC value and he is comparing. If both seem to be found to be same, then he comes to know it is from the authorized person. And the second way of using message authentication and confidentiality has been ensured. The same diagram, same extension of the first scheme has been second. So after appending the MAC function along with the original message, the entire content has been encrypted, because there is a here in the first scheme the message has been sent simply in an environment where there is a possibility of the third party to read that particular messages. So I am taking a measure over here. I am encrypting the entire content. So if any third party compromises the network, he will not be able to see the original message, that is plain text. So he will be having the encrypted form of text along with the MAC function. So that is the advantage over here. And here the last scheme, the message authentication and confidentiality. So this here again, what I am doing, instead of encrypting the entire content along with the MAC messages, here I am encrypting the message at the beginning itself, and then that encrypted messages, for that I am calculating the MAC function, and that has been sent, appended and sent in the environment. And at the receiver side, the same reverse process has been taken place. So these are the three uses of message authentication code. So we have discussed about what is the authentication requirement. Because of the kinds of attacks possible in our network, we have to ensure authentication in both the sides. How we can establish authentication? By use of three schemes, that is hash code, MAC, message authentication code, and message encryptions. These are the three predominant groups of classes that can be used for providing authentication or ensure authentication in the communication environment. So we will discuss about the further topics in the next video lectures. Thank you.